Letter E. Okay, let's take a look at letter E.
I will leave the exponent on it, so you know that I got that one wrong.
Oh, that's fine. Just so you know. Sure. Well, also make a note then that you've corrected it. So if you did correct it, now 24 is in there, you need to know that that is in fact right. So this one, BEDMAS says brackets, exponents, division, multiplication, addition, subtraction. There are brackets, but there's no math inside. So now let's look at the exponents. I've got an exponent on that set of brackets, so that thing has to happen first. So negative 3 cubed means I've got negative 3 times negative 3 times negative 3. If you want to punch this thing into your calculator, you're welcome to do that. Exactly as it's written. Bracket, then the minus sign, then 3, then close the bracket, and then to the power of 3. You can punch that into your calculator or write it out like this. Negative 3 times negative 3 is positive 9. And then positive 9 times negative 3 is, it's going to be negative 27. So I'm going to have negative 6. And now when there's no symbol in between that number and the bracket, it means you're multiplying. There's going to be negative 6 times negative 27. Now, I don't know what that is, so this is where I would say I let you guys use a calculator. This is beyond what's on your multiplication tables, and I don't expect anyone to know their 27s times tables. So you crank that thing into a calculator, negative 6 times negative 27, negative times a negative is a positive, and you'll get 162. So Hills, that make sense? Just the ordering there? Okay. Is there anything else off this page anyone would like me to do?
Letter C.
Letter C. Oh, that whole column. Okay.
Because I just broke down. 6 times 6.
Yeah.
Oh, again, it's
You figured it out?
sometimes my brain will just put me into pump.
Yeah. The brain does that to a lot of people.
Yeah,
But you,
it was the wrong row. It would be 6 plus 6.
yeah, 6 plus 6 would, yeah.
And I looked at it, it's the same thing.
So then, Jordan, one of the things that I might suggest you consider doing is reading the question out loud to yourself. Like while you're doing it, if you can get out of your head, like when you read it to yourself, you'll understand it differently than just doing it in your head. I don't know. I have found that to be a helpful thing to recommend to students.
6, 12, 18, 36.
Correct. So that's going to become 36. The subtraction stays a subtraction. And because there's no brackets around the 5 and that minus sign, the negative is not part of the squaring.
25.
It is, in fact, 25. So then 36 minus 25 is 11. Okay, is there anything off this page anyone else would like me to do?
I.
Letter I. I didn't assign I.
I got it.
Do you want to see I?
Sure.
Okay, so I haven't assigned I. We're going to skip I, but you could do questions like I. Let's take a look. So I've got a quarter plus a quarter. Fractions. People love fractions, right? When you're adding fractions, we need a common denominator. And we have a common denominator. They're both 4. So once you have a common denominator, when you're adding fractions, you just go across the top. So what's 1 plus 1?
2.
So you're going to get 1 plus 1 is 2, and the denominator stays the same. So I've simplified what's inside there.
Then you got to add it 3 times.
No, we're going to multiply.
Right.
But there's an easier way to do this, because if we could say, okay, my exponent rule says that when I've got a fraction to a power, I apply it to the numerator and the denominator. I could do that, but before, as often as you can, and before we do that, it's important to ask yourself, can I reduce whatever fraction I'm working with? Yeah. 2 over 4 is going to become what?
1 over 2.
You bet. So do that. Because a quarter plus a quarter is a half. And now I can apply my exponent onto my numerator and onto my denominator. which is a lot easier than doing 4 cubed. Because this is going to become 1 cubed over 2 cubed, and 1 cubed is 1 times 1 times 1, which is, careful, 1 times 1 is 1, times 1 again is 1. Enough, Liam. Was that Liam? Was it harsh this time? 1 times 1 times 1 is 1. Anything times 1 is itself. And then 2 cubed is going to be 2 times 2 times 2 is 8. So that's how you do a question like I. The rules haven't changed for fractions. I just, didn't force you to spend time looking at them. Okay, so those are the top 8 questions. Flip the page. You had a couple days. It was Wednesday, Thursday. And I wanted Mr. Whitman to have you guys work through and help you if necessary the back page. So I'll give you the answers to those and I'll do any of the questions you may have. -11, 36, 58, 70, -35, and 44. Are there any of those 6 anyone would like me to do? Yes, Denny. I can. These guys are starting to get more involved. But we've got BEDMAS to help us. B in BEDMAS stands for brackets, and we have 2 sets of them. So we're going to write down the pieces we haven't used yet. So that -4 out front is going to stay there. And now I can simplify what's inside this bracket. It's addition. So 1 plus 4 is 5. That squared is going to stay out there. I'm going to have it divided by 5 here. Nothing's changed there. Minus. And now I've got 10 plus 5, which is 15. So I've got now, I simplified that bracket, I got the 5. I simplified this bracket to give me the 15. Brackets are done. Now exponents. I have an exponent here. It is just on the thing right to the next of it. Because these 2 are being multiplied, so this has to go to this exponent first. 5 squared is 25. So this is going to become -4, and then in brackets here we're going to have the 25 divided by 5 minus 15. I changed one thing, and I wrote the rest of it as it is. Done. Now, when we have division and multiplication, we just go left to right. So -4 times 25 is going to be what? It's going to be, well, -100, yeah. Because a negative times a positive, so it's -100 divided by 5 minus 15. Now, you've got a calculator, or you can know. It's also on your multiplication table. -100 divided by 5 is going to be -20, good. And then we've got the minus 15, which we haven't touched yet. A negative divided by a positive is a negative. 100 divided by 5 is 20. And now I've got -20 minus 15. We're at something negative. We're going to go further negative. It's -35. Danny, does that make sense? It's kind of the procedure there. Yep. Okay. This cough is hanging on. Does anyone want me to do any of the rest of those 6? We're okay. We can do R. Let us do number R. Okay. So, BEDMAS. B for brackets. Are there brackets with math in them, Garrett?
1.
Yes. What's 0 minus 3? Is not 3. It's -3. Okay, so I simplified the brackets and I left everything else alone. Now, brackets are done. Do I have exponents? Yes, I do. There's one on the 2, and there's one on that 2. Because the minus sign isn't inside a set of brackets, it's not included. So 2 squared is, and I still have the 5 times out front. 2 cubed is 8. And I still have that minus sign there. That's going to be 8, and I still have the minus 3 there in brackets. Now I can do some multiplying. 5 times 4. Now when you multiply these, we really should include that sign that's in front of the 8. So it's not just 8 times negative 3, it's negative 8 times negative 3. A negative times a negative is going to be a positive, and 8 times 3 is 24. And then we add those two together and get 44. Does that make sense, Carrot? Okay, and then letter T was fractions. I didn't want you to do it. But we can take a look at S, U, and V. S was 59, U is 1, and V is 0. Does anyone want me to do either of those, any of those 3 questions? U? Well, without doing any math inside the brackets, what you need to notice is that there is a set of brackets, and there's a 0 outside. The exponent law we're going to use here is anything to the power of 0 is what?
1.
So it doesn't matter, no, it's 1, Hassan. It doesn't matter what's inside those brackets. You could do 1,000 operations inside there. At the end of the day, because you've got brackets and an exponent outside of 0, it's just 1. I don't even know what this is. I didn't do it. Anything to the power of 0 is 1.
Well, you want to do the answer bracket?
You want me to do add numbers inside the brackets just for you?
Just for fun.
Well, you would multiply first, and you're allowed to use a calculator. So 21 times 17 is 357, and you'll add the 11 to it afterwards. Get 368 to the power of 0, which is 1. Okay. What is so funny back there, gentlemen? We good? Are we okay?
No, I think you have.
I think we're, no, nobody asked you, Garrett. Nope, don't do it. Nobody. As long as the back row is good, we can stop making comments. We're great. Okay, so flip the page. Let's walk away from BEDMAS for a second, but not for too long. Because what would math be without BEDMAS? Find me this page here, lesson 5, square roots. And you're all going to want a calculator. Every one of you needs a calculator. So get a calculator. And leave your phone in the little slotty thing when you take a calculator. You want to leave me your beverage? I want your phone, Hassan. You have no phone on you? I don't believe you. What that? In your pocket there? That's gum. That's a credit card? I'll take your credit card. Leave your phone. And don't lie to me or I'll take your phone and send it down to the office. What's your phone? Yeah. You don't have a device on you? Here, put your name on the board. Okay, everyone needs a calculator. Hassan, regardless of whether or not you take a calculator, I want your phone and the thing.
I didn't take one.
I don't care whether you take one or not. I want your phone. You lied to me. So there wasn't one. There is one. Go put it in the little slotty thing and either take a calculator or not. It's up to you. Okay, so square roots.
You took all the quick ones.
Well, that's why you should have been a little quicker. It's the same one Liam's got. It's a great calculator. Okay, so Square roots. The reason square roots are in this lesson is because squares and square roots are exactly the opposite. Now, when we're looking at square roots is the same as this symbol here. It's whether it's this symbol, this is the root symbol, or, gentlemen, Hamid and Abdullah, it's the root symbol with the 2 there. Both of these mean the same thing. When there is no little 2 there, it's implied that this is a square root. But you can put whatever number you want there. You can put a 3, a 4, or 5. It'll change the kind of root that it is, but it won't change how these things work. Guys, Hassan, are you giving Liam empty bottles?
No. Then he finished it.
Okay, so we've seen roots before, yes? Okay, so how does a root work? If I have 4 and I want to take I have 4 and I want to take the square root of 4, what is it? Dakota, it is in fact 2. Why? Why is the square root of 4 2? Because 2 times 2 is 4. Cool. So let's put a because here. 2 times 2 equals 4. So what the root does, please stop. What the root does is it gives you back the number that multiplies itself to whatever's inside the root. I'll show you what I mean by that. So the square root of 9 then is going to be what? 3, because 3 times 3 is 9. So we say the square root of 9 is 3. Cool. Square root of 16 is? Square root of 25 is? What times itself is 25? So then 36 and 49 are probably going to be, and 6 and 7. Now, you guys have multiplication tables that you have access to. You also have calculators. So let's show you the multiplication table first. For those of you who enjoy using them, these numbers here, 4, 9, 16, 25, 36, 49, these numbers are all where on this table? Well, I've got, what are those numbers again? 4 is there, 9 is there, 16, 25, 36, 49, and so on. Yeah, that's exactly my point, and so on. If you take a look at the 6 numbers I just shaded in, they are all on the diagonal that goes from the top corner down to the bottom corner. Yes, Jordan?
What about 1?
Sorry, what about 1? 1 just wasn't on the chart here yet. So let's talk about the 1. What is, okay, gentlemen, why do you have 2 calculators now, Hassan? No, that was the one that Liam had a second ago. Where did the black one come from? Oh, so you don't need it. Okay. Ethan, where are you going? Okay, so these form the beginning of the whole rest of the diagonal. We could shade in that entire diagonal. 64 is 8 times 8. 81 is 9 times 9. 100, 111, 144, 169, 196, 225, 256, 289, 324, 361, and 400. We have a name for that whole diagonal. What do we call those numbers? Sorry, Sal? They all have square roots. Some of them are even, some of them are odd. That is a true statement. We have a name for these kinds of numbers. No, we call, those are something else. We call these things, so these numbers here, these guys here, we call perfect squares. And that whole diagonal is part of it. Anything on that diagonal that can be written as a clean number times another number, times itself. So like 81 is 9 times 9. 100 is 10 times 10. Any of those numbers, we call, on that diagonal, we call perfect squares. So a perfect square root then is finding the whole number that multiplies by itself to give the original number. A perfect square root is a number like these, 2, 3, 4, 5, 6, 7. We call these are integers, but rationals. We don't want anything that, we don't want any decimals in here that go on forever. So, if you recall, to find the area of a square, if you look here, I've got a square that's made up of 4 smaller 1 by 1 squares. Hamid and Abdullah, please stop talking. So then the area of this square here is 4. It's made up of 4 little 1 by 1 squares. We can count them up. This thing has an area of 4. And the reason it has an area, if you recall, for a square, an area is the length times a length. Well, to get the area, we need to have a 2 by 2 square. So what the square root is actually finding for us is that, the question that it's asking is, what is the side length of the square if the square has an area of 4? That is where the idea of the square root came from. The square root tells you what that side length needs to be. So this guy here has an area, it's a square with an area of 9, and the only way a square is going to have an area of 9 is if the side length is 3. So this thing's going to be 3 by 3. That is where the math that we're looking at here came from. Now we can apply these ideas to fractions and decimals as well. Let me zoom in here. If I have something like this, if I've got 9 over 16, is this thing a perfect square? Well, let's look at it piece by piece. I'll zoom in on it so we can see each one individually. I've got 9 over 16. Is 9 over 16 a perfect square? Well, how do you... Oh, figure yourself out, document camera. How do we multiply fractions together? Because that's what we're asking, that's what we have back here. Can I find a number that multiplies by itself to give me 4? Yeah, it's 2. Can I find a number that multiplies by itself to give me 9? Yeah, it's 3. Can I find a number to multiply by itself to give me 9 over 16? Well, let's find out, shall we? Fraction math is just, I got a fraction times another fraction. When we're multiplying fractions, we just multiply across the numerator, we multiply across the denominator. Can I find a number multiplied by itself is 9? Yes, Garrett? It's 3. 9 is 3 times 3. Can I find a number that multiplies by itself to get me 16? It's 4. 4 times 4 is 16. So then is 9 over 16 a perfect square? Yeah, it is. This thing right here is a perfect square. And 3 over 4 over here is the square root. Or another way to look at it, if the numerator and denominator are both perfect squares, then the whole fraction's a perfect square. Cool. So how about the next one? Is this thing, so Gary, you say this one is a perfect square because So then what is the square root of 144 over 36? 144 is going to be 12. And then what times itself is 36? So the square root of 144 is 12. The square root of 36 is 6. And we can simplify. So this is the perfect square. This is the square root. And we can simplify this thing further. What's 12 over 6?
Wait, add the root?
No, just it's gone. The root's done now.
So you mean simplify.
Yeah, so it's 12 over 6.
6 over 6. I mean, yeah, 6 over 6.
Keep going. A fraction is just division, right? What's 12 divided by 6? It's 2 over 1, which is just 2.
I was actually going to say like 6 over 3.
But you can keep going with 6 over 3. What's 6 divided by 3? A fraction is just division. We can take it all the way down to 2 over 1, which is just 2. So we don't need 6. Why are we hung up on 6 over 3?
That's the first thing I put in my mind.
Yeah, but you still have to keep it going. 6 over 3, these are still both divisible by 3 then. You'll take it all the way down. Yeah. So look at these last two.
Teacher, you just broke my pencil.
How about 4 and 9 over 16? You want to say yes, Garrett, because each one of those pieces are perfect squares, right? 4 is a perfect square, 9 is a perfect square, 16 is a perfect square. But what do we always have to do with fractions? If it's mixed, make it improper. You bet. So we have to take our mixed, and we have to turn them into improper. I don't need running commentaries, guys. Son, you broke his pencil? Where's your pencil? You're not writing anything down that I'm writing down? Do you have another one to give to Liam? But you broke his pencil. Do you have another pencil you can give to Liam? You owe him a new pencil. Okay, so take it mixed, make it improper. 16 times 4. Well, this is a little bit more convoluted to do, but you have calculators now. What's 16 times 4? It is, in fact, 64. Well done. And now we're going to add that to, remember, we multiply here, and we add to the top number. You betcha. So this is going to become 73 now over 16. Is 73 a perfect square? Well, if we look at our list, it's not on there. So no. Even though, and that's the tricky part, Garrett, every part of this looked like a perfect square, and so we wanted to believe that it was a perfect square. But with fractions, if it's mixed, you have to take it, make it improper. We can see here, not a perfect square. Okay. And now the one that sucks, which is actually the thing that you guys seem to want to work with more often, is the decimals. The decimals are not quite as clean. So I don't want you to write this on. No, have a seat. I'm trying to teach you something. No, you can't leave. I'm not going to get you to write this next part down. I just want to show you something, and then we'll use what we come up with. To come up with a rule for this. So I want to line this up here. I would like you, Hassan, to give me a one-digit decimal. 6 is not a decimal. 0, that's 2 digits. Thank you, Denny. 0.6. And we're going to multiply 0.6 by itself. Okay? So effectively what I'm doing here is I'm taking 0.6 and I'm squaring it. 0.6 squared is 0.6 times 0.6. How do I multiply decimals? Zach, I don't want you paying attention, even, just throwing you right attention. What's 6 times 6? You betcha, it's 36. And the way we multiply decimals longhand, Hassan, eyes up here. The way we multiply decimals is that we multiply the numbers, and then we look how many decimal places we have. There's one here and one here. So 2 total. So in our final answer, we go down to where the number begins, and we go over 2. Okay, so 0.36. So 6. 0.6 is 0.6 is 0.36. Fantastic. Hassan. I would like a 2-digit decimal.
0.05.
Hassan.
0.07.
Just to be difficult, eh? 0.07. Here we go. So this is 0.07 squared. 7 times 7 is? 7 times 7 is 49. And I've got 2 decimals in the top number. Jared, wake up. Got 2 numbers. You can see through the hood. Okay. And I got 2 decimals here. So 4 decimals total. So 1, 2, 3, 4. Fill in the zeros at 0.0049. Interesting. What does this number and this number have in common? They are in fact both decimals. I need a little bit more than that. Sorry, Dakota. They are both perfect squares. So perfect squares that are decimals have yet one more thing in common.
They can be divided by each other.
Nope. I hope not. Nobody knows? Oh, nobody can see, okay? At the risk of losing, all cohesion. 3-digit decimal place. Someone not Hassan. Liam.
0.666.
So close. Okay, so let's multiply these things together. This is going to be 0.444889. Okay, so it's an emergency. Yeah, so you can hold it. Well, why didn't you go to the beginning class then? No, hold it. I'm almost done. Hold it. Okay, yes. Oh my gosh, guys. It's 10 to 1. 10 to 2. What do these 3 decimals have in common? It's 10 to 2. How many decimal places here, guys? 2 decimal places. How many decimal places here?
3.
4. You. How many decimal places here? 6. So for a decimal to be a perfect square, it has to have how many decimal places? 2. 4. 8. Thank you. Thank you. Thank you. Back corner. I don't think you said it. For a decimal to be a perfect square, decimals must, now this is where you're back writing again, have an even number of places. That's the first piece. They must have an even number of places, and if you ignore the zeros, what's left must be a perfect square. So for a decimal to be a perfect square, this is what needs to be true. It has to have an even number of decimal places, and if you ignore the zeros, what's left must be a perfect square. So 0.09. If I ignore the zeros, it's just 9. Is 9 a perfect square?
No.
9 is 3 times 3.
Yeah.
So it is. It's up at the top of the page. And I've got 2 decimal places there. So I've got an even number of decimal places, and 9 is a perfect square. So this thing is a perfect square. Hooray, it totally is. And the square root of 0.09 is, this is where I want you to pull out your calculators if you haven't already. I'll show you how to take square roots on your calculator. So, square root, here we go. All your calculators are going to do it slightly differently. Liam, grab a calculator. The Casios have a square root button. It's right there. I push the square root button, and I put in the number that's inside the root sign, 0.09. I'm going to close the bracket. I'm going to hit equals, and you're going to see that the square root of 0.09 is 3. Now, this symbol is going to look like different things on different calculators. Or sorry, it's going to show up in different places on different calculators. Is anyone struggling to find? Yeah. Harsh, did you do this? Hassan, you did it too? Ooh, your calculator says 3/10. Fantastic. There's an SD button then that you're going to push to go back and forth between.
What does this say?
0.3. So on Jordan, Denny, why are you touching anybody else in the back row?
He did to me first.
I know. So that's the reason. Okay. Liam, Denny, Hassan, Harsh. Keep your hands to yourself. Don't touch anyone or anything that doesn't belong to you already. Some of you might have, if you have a TI, the root button will be along the side down here. It might be below the, you don't need 3 calculators. It is on the TI calculators, the root doesn't get its own button. It goes right, if you look here on the TI, it's above the square button. So to access it, we're going to push second. And then we're going to push the square button, and it'll give us the square root. We put in our 0.09, we close the bracket. Square root of 0.09 is still 0.3. The square root of 0.09 is 0.3. What kind of calculator do you have? If you can't find it on your calculator, let me know. Jared, have you found it on the calculator you're using? No, because you're not holding the calculator. You got it. Your square root button is right there. Same as the first calculator I showed. You're good? Okay. So on your calculator, I want you to check. And after you've done this, Harsh and Jared, if when you've done it, you can go to the bathroom. I want you to check. Are these numbers down here perfect squares? If the decimals end, they're well, check them all. Check them all.
Okay, this is what I have, right?
No, you push this. So on this calculator, you just push the squared button, and you need to write inside there 0.09. There you go. So yours actually opens up the little space inside, which you push the SD button. There you go. Okay, check them all. I'll give you 2 more to check here on the bottom. Square root of 0.144. I want you to check that guy there. I want you to check this guy here. And I want you to check this guy here. Check each one of those and tell me if it's a perfect square, and if it is a perfect square, then what the result is. Jared, you've done them all? Garrett, you got 3 minutes. You've done all 8 of these? Crank them all out. In a second. I'm almost on the lesson. Okay. And when you're done this page, did you finish them all? You said which ones? Which ones are not? This one is a perfect square. You got a square inside there. Okay, we're watching. Riley, you watch.
Alright, I did it.
No. Okay, let's take a look. Okay. Yours. The way this calculates your workload, you bracket question like this. Fraction is just division. 1.1 divided by 4. It's going to take the square of 121. Right here. Bracket. That decimal does not end. So it's not a perfect square. That's why I said check numbers below our perfect squares. If it's not a perfect square, just say it's not a perfect square. Guys, perfect squares are numbers that are going to have decimals that end. If it doesn't end, it's not a perfect square. Okay. Garrett, see you tomorrow. So, lots of you guys are done. That's great. What did we find out here? Which ones is the square root of 1 a perfect square? Or is 1 a perfect square? Yes, because the square root of 1 is 1. Is 4.04 a perfect square? The square root of 4.04. Now that is not a perfect square. Perfect squares have decimals that end. So this one is not. How about this guy here? Square root of 121 over 4. If you punch that thing into your calculator, what do you get? Well, then punch it into your calculator. What do you get? What is the square root of 121 over 4? Yeah, Dakota. It's going to be 11 over 2, you betcha. Which, if you punch in your calculator, should tell you it's either 11 over 2 or 5.5. Excellent. The square root of x squared. It's not supposed to be a trick, but it's kind of a trick. Squaring something means this thing is a perfect square. We haven't talked about it, but we will right now. Squaring and square rooting are opposite operations. They cancel each other like adding and subtracting do. So, yes, Ethan. Yes. So the square root of x squared is just going to be x. It was a trick. I tossed it in there. And is 7 a perfect square? No. I threw 3 more down on here for you. Is this one a perfect, even though it looks like it, is this one a perfect square? No. It's got an odd number of decimals. Is this one a perfect square? Yes, it is. It's got 1, 2, 3, 4, so it's going to be 0 point. If you punch into your calculator, you're going to get 0.12. And this guy also doesn't look like a perfect square because 18 is not and 8's not. But what do we always have to do with fractions? Only when we add or subtract them. Jordan, what should we always do with fractions? Someone said simplify or reduce, you betcha. 18 over 8 can be reduced to? Try one more time. I can divide 18 and 8 both by, I could divide them both by, not 9, by 2. If I divide this thing both by 2, the question becomes the square root of 9 over 4. Hey, wait, that looks familiar. Is 9 over 4 a perfect square? It is, in fact, because 9 and 4 are both perfect squares. 9 over 4 must also be a perfect square. So this guy's going to be 3 over 2. Okay. Here's what I want you to do. We are not going to estimate. I want you to flip ahead. I want you to find on page 15 this. We are going to skip the estimating. We are going to go straight to evaluating. I want you to do these in the 20 minutes that, the 15 minutes that remain. I would like you to look at those 8 questions. You get a calculator. I want you to show me your work, Ethan. Go to the washroom. This is your task. Zach, did you go to the washroom already? Go to the washroom now. Take a look at these 8 questions. You have the calculators at your disposal on your market set giver. We're skipping the estimating. Jump to this. Okay. Merciful. Yes, you go to the washroom. It is 2:05. Sorry? That clock also doesn't say 8:50, but it is not 8:50. That clock says 10:43. Because the little hands between the 10 and the 11 and the big hands between the 8 and the 9. You need glasses, Liam. Which you've said before. Page 15, Jordan. I want you to do these 8 questions. Respond in writing to the email. Okay. Donna still didn't email. So it's not a perfect square. Just punch in your calculator and tell me what you get. It just says to evaluate. So just, yeah, so what is that number? Write them all down. Yeah, just write them all out. 2 point what? Some of them are easier to do without a calculator. But it's entirely your call.
57, 97. That's what I got.